joining. My two other colleagues are taking us on key areas on SQL using the Microsoft Server, SQL Server. So today, let me share my screen. Let me share my full screen. So okay. Confirm if you can see my screen, everyone.
I can see your screen.
All right. So today's class, we'll be talking on database design and optimization. That's what we're discussing about. We've talked about manipulation in the previous sections. So what we are to talk about or to do today is very simple. And one is introduction. How do we design a database? What are the various data types? The keys and constraints in database, what they do, how to use them, and all. We'll be talking about this. We'll be talking about referencing cardinality. That's where we try to create relationship between primary key and foreign key. We'll be talking about that. And we'll be talking about how to optimize our database. And when we talk about optimize our database, like how do we make our database light so that it can give us our result faster? That's just what optimization is all about. So my own quote is this: anyone who stops learning is old at 20 or at 80. Anyone who keeps learning stays young. So I added this and it will be more relevant. So we should never stop learning. This workshop is going to end, and still yet after this, let our zeal, our mind still be open to learn as much as we can. So this is just brief about me. I'm a data analyst, and I have interest in being a corporate global strategy enthusiast. I've spent 3 years as a data analyst, and I hold a mini MBA at the Acadia Institute. I'm a student at SDC Startup School because I really have interest in startup growth, and so I'm passionate about community building and all, which is the reason why you see me here as a facilitator to deal with some of the things that I really love to do. So I've actually organized tech outreach too at center schools and for tertiary students. So we're able to get approval from the ministry and also get sponsor to sponsor the event. So that just brief about me. Yes, I'm here together as well to learn with us and to rub mind together with us too. It's promising to be a great section. So we talk about database design. What does it mean? It's something that anytime we see words like this being coined, we can try to simplify them together so that we can try to know the meaning. What is database? What is design? So once we know the meaning of database, when we know the meaning of design, we can match the two together. So database is where database stored, right? And what is design? Design does what? Redesigning it, restructuring it to contain database. That's exactly what it means. So this is what I wrote about: is careful drawing layout structures that contain or house database submitted by the end user or an application. So I was citing a form. I said, e.g., a registration form. Example of this, now let's say our Google form. A user is filling the form. What's your name? What's your email address? Somebody has designed the database where such data, upon submission, where is it going to? So I continue to say it's also pertinent to have the idea of the kind of data to be collected ahead. Maybe it's picture, numericals, alphabets, dates, to design a database to fit well. So what I mean by it is a column that will accept alphabets. We won't put integer there. The data won't work well. That's what this person like. We need to know what kind of data is coming in. Then we can design our database in that way so that what it will meet what they are submitting. It's not a column whereby people should put dates. then they are putting alphabets there, it will not really work. So reason why this is very important, we need to know what kind of data are people bringing in for us, what kind of data are we collecting from our user. You need to know. Then another point is database design also require having entire knowledge of the project overview flow to know how to create a smooth relationship among each tables. Sorry about that. And also the database can load faster when being queried. So what am I saying here is, for example, if you are designing a database for Jumia or you are designing a database for a company, you need to know all kind of data that they are working with so that you won't have, let me say, repetition of data. You can have your fact table, you can have your dimension table. Once you know, okay, we need the data that will capture return, we need the data that will capture sales, we need the data that will capture order, we need the data that will capture, as much as all these tables that you are working with, they are very long, right? You can see sample of our database here, how they are interconnected and all.
Hello, can anyone hear me? I can't hear properly.
Of technical, as they are responsible, for ensuring the most efficient and secure data system. Can you hear me? Can everybody hear me?
Hi, Paul. We lost you for a moment.
Wow. Okay, I'm back now. You caught me. Sorry. So I said, let me take a few steps back. Database design require having entire knowledge of the project overview to know how the work will flow, so that you can know the table to model to. It's not that so table is collecting what table is collecting data that table C is collecting. So you're having duplicates, you're having redundancy in your data. So it's required for us to know what kind of data, what kind of table are we working with, which data is already existing that we can just model to and get our result faster. Because once we're having redundancy in our data, it will affect our database, which was what I said here, so that the database can load faster when we are being queried. We need to know. Then I said we have opportunities in database, and that's database architect and database administrator. So database architect is somebody with high level of technical expertise. They are responsible for ensuring the most efficient and secure data system for a company like Jumia now. Is somebody that will design the database, how it will go, how it will work. Okay, this kind of data we should use, this kind of data that fits our work, our project that we're embarking on, this kind of project that fits into it. So it's database architect that does that. Then we now have database administrator, and this person has ability to manage and use data system and also troubleshoot any technical issue that arise. Anybody that needs data, now maybe they needed sales for last month, they want to analyze data, then this database administrator will be the one that will pull the data out for them to use. Okay, this was the record of yesterday sales, this was the record of last week. So this person database administrator was able to write queries, must be able to write all the queries in database very well. That's what this space is saying. So that's just how to design a database, just like we designing a house, where room should be, where kitchen should be, where toilet should be. Likewise, in the real world, okay, we're having products, we're having customer, we're having sales accounts, we're having gender table. As more tables that we are having, the person that design it needs to be knowledgeable about this area. Then what are the components of a database? We have entity, we have attributes, we have relationships. So what are entities? Entities are those real world objects or things with distinct characteristics. Example is just what? Customer, product, student. So I can liken these entities to be table. I can liken entities to be table in the real world for us to understand. You can have a customer table, you can have a warehouse table, as much entities that we can have. Then we have attributes. What attributes are what? Characteristics and properties that describe an entity. So if, for example, now we created an entity called what? Customer. So we know that any attribute that will be inside this customer will be what? Relating to customer. It can be customer name, customer phone number, customer address, customer bank account, customer date of birth, like that. We have it as attributes after we've created it. So this one can be likely to be what? Rows inside our table. If entity here now is our table, then all these attributes will now be what? Will now be rows inside it. Then we have relationship. It represents association and connection between entities in the database. It shows how entities are related to each other. So what this page is telling us is we can have 3 tables and we can be working with 3 of them together. Just the way that we are using VLOOKUP. I'm sure must have been taught how to use VLOOKUP. Exactly like that too can be done in database. We can relate 1 or 2 tables together. We can put data from table A, from table B inside one table to get one single result. That's what this relationship is telling us. It's just we doing what we call modeling our fact tables and our dimension table together. That's what this page is saying. So I quickly came here and said, how do we design a database? Know your data table, which are entities, e.g. maybe supermarket, school, company that you are working with. Know what kind of work you want to do with them. Know the data type that are needed for each entries. Use good columns, attributes, or table name for easy reading. You can see now, I use example here, TBS staff. So anybody that is reading my script, let me call it scripts, my queries, they will know like, okay, this table means staff table. If anybody is seeing first name, they will know, okay, this is employee first name for my heading. So we don't need to create an attribute or entity in such a way that people will start calling us and like, please, what do you mean by this staff? Is it table? Is it field? Is it what? What does it mean? So we need to simplify by using what? Keywords that will simplify people to understand this what we mean. And inside the database, we have something we call record, we have something we call field. Then what do you mean by record? It's just like telling somebody like, okay, bring me the record of Kazim. That's what this way, all the data about that person that is bringing it out. A field contains data about one aspect of the table, maybe first name or email address. That means we are not dealing with the entire record of that person. We only need one value from it. So I think I have a picture here that shows us easily so that I can understand what I'm saying. So this is an example of entity that we can have. We can have patients, you can have a table for customer, you can have a table for video, you can have as many tables as I can. Then each attribute comes in like, let's say for this example I started here, now we have customer. So for under customer, we have a customer ID, customer name, customer surname, customer date of birth, customer address, customer phone number. You can see how it's going. This is an example of field so that you can understand. See field now is only this column that is field. Y record is the entire row. Y record is the entire row. So when last section that Mr. Jide took us, the data we are returning, they were records of that table is using select star from so. It's actually pulling data from what? It's pulling the record from that table. Then this is the example of how relationship look like. So this is an entity here, student. Then this is an entity here called what? Course. Then we now create a what? A relationship that models all of them together. So this is how a database look like. This is how a database look like. Once you have your fact and dimension table, the same way we've been taught in our Power BI, likewise, we have it too in SQL. So this is it here. See the way it has been modeled to each other. We've connected them and all together. So in our database, that's what we call entity relationship diagram. You likely to see this sign, and these are what they mean. Once you see this, means one, many. This one means what? One and one only. 0 or 1. This one means one to what? One or many. 0 or many. So that's it for that aspect. Basic thing to know when we are designing databases, data types, primary keys, foreign key, constraints, check, defaults, and not null. So when we talk of data type, let me come here and explain data type to us. We have various types of data type. We have numeric data type, we have data type, we have characters or string data type, then we have binary data type. So simply I'll just rush through because we need to do some calculations and write some queries. When we talk of numeric data, it deals with numbers. It deals with decimal number, maybe 1, 2, 3, if you are working with it, or maybe 2.5, 3.7. If you know that you are working with that kind of data, these are sample of what you use to design your table. Int, 9int, decimal, and float. But major what we use more is int, decimal, and this float. Because decimal and float, they are set decimal points. Why it is only maybe 1 to 0, 1 to 10, like that. But for when you are dealing with decimal and float, there is limit to what decimal can, maybe 2.356 decimal can. But once you have a higher, larger decimal number, you might need to use what? Use this float. Then we have dates. Maybe you want to collect date and time from your user, or a column to contain date and time. This is the data type that we are going to use. Date, time, and you can see date means date. October 10, 2023, that is date. And time means like 1:30. Why this date time means we are combining these two together. That's what this date time means. Then we have character and strings. What are characters? What are strings? That's when we talk of anybody submitting alphabet in short. Let me just put it like that. If you want a user to type his name, you want a user to type his address, these are what we use. Varchar. So this varchar is popular one that is being used more. This varchar is common one that even I personally use it when designing my database. So that's it. Okay, this binary data type deals with, maybe we are working with images. You want user to be able to submit their passports, their pictures. So you work with binary, deals with yes or no. Why this blob deals with picture? You want upload passports, upload your picture, upload your video. So you make use of this blob for your database. So I know we are seeing something here called NVARCHAR. They are Unicode. And I saying, which is international character encoding. You must have been seeing this thing when we are doing our writing, like UTF-08 and co. So that's just what it means. But majorly, if we are working with our database, we should just stick to using what? VARCHAR or CHAR. They are the best to use for that aspect. So let's get to our database before we come back and look at the other primary key. So let's try to work with so I'll be creating a database and we'll be quick with it. We're having less minutes to go. So create database. I'll be creating a database. I'm going to call it Superstore 3 because I already have a database I've already created, but so that we can see it how it's been done. So okay, good. So I've created a database now. So if I refresh my SQL, I come to this place, you can see now we have this now, but there is no table inside it. So we'll be creating a table inside this place. And this is one thing about MSR. Everything you can create your table using the interface. Right click on that, you see create new, then start calling it one by one. Let's say I want to create customer ID. Then what kind of data type is it? Is int. I want to use int. Then I can come here and make it a primary key. Set as primary key. So let me take that to explain what we mean by primary key. Primary key is a unique identifier inside the table. It doesn't have duplicate. So once they call, it's just like giving a student a matric number. That is the primary. Nobody in that school will have that matric number that student has. So exactly when we are creating a table inside our database, it must have a primary key, which is what actually wanted to talk about here, but I wanted us to work with data type first. This is what I have here, foreign key and primary key. But since we are working with it here, so I branched to talk about it. So when we talk about a primary key, they are unique. You can't have double of it inside a table. So anytime you are declaring a primary key, just know that that table we never have a that column, we never have a what? We never have a duplicate. Then once allow nonce is a constraint. Allow nonce is a constraint, and your primary key must not contain none. What did I mean by none is that your primary key must not have empty column, empty cell. It must be filled. If you're having 10 rows, then the primary key too must be what? 10 rows. It must be filled. There must not be blank in that column. That's what this primary key is saying. You can see where I'm trying to check. It's telling us that allows no property cannot be set on column, which is part of the primary key. So primary key can never be null. Then what is null? And that's what takes me to what I'm explaining here. Null and not null. Null means what? Allowing user to submit blank, leaving a column blank, such that the user will not fill any value inside. You'll be seeing the practical aspect of it too now. So I'm creating another column here. I'll call it let's say customer name now. I'll call it customer name. Then I'll use voucher for it. Then I'll use voucher for it. Allow null. You can see now I've checked this one. What this one is saying that the user can decide that he's not filling his name, then it will enter into database. But if I uncheck it, it will not go. It will tell me that that place is what? Is blank. So I will do one null. I will do one that is not null. Then this one I will say phone number of that customer now. Phone number. Then this one will be using the what? The int. Because we are dealing with the number. So this one, let me check, it should not be null. So I think we are good now. So let me save. So let me save this place up. Customer. So we've used the GUI of MSQL to create this our table. So it'll be under substitution table that we'll be creating. We write code to create it so that we can see now the table is now here. We now have the table inside our database. Then I can close this place and come here now and see select star from this data table now from customer. So let me switch to it. So I might need to switch here, so I won't be switching every time. I might need to select it from. You can see now there is nothing inside our table now. Then we'll quickly insert few data into it. Insert into. So the ID 1, comma customer name. You put it in a string. If you are writing it manually, but though you know it's application that will be submitting for you, so you won't be filling all these ones yourself. So let's do show, comma. Then I set this one to null, that it should allow null. Then I'll put the last one is phone number 8081123456. Close it, then run it. So column name and number supply does not match. Okay, so let me come here, let me put it here. So just fill in so do you know why it's giving us that error? I have three columns here, 1, 2, 3. But the value that I'm submitting is only what? Is only 2. That's why it's actually giving us that. But it's because I want us to show us the null and the not null aspect of the data. So I'll call the name here cost ID, customer name, phone number now. I'll call it this way. You can see saying there are more columns in the insert statement than the number in the value clauses must match the insert statement. So let me put the name here for a customer name. Incorrect near for insert. Why inserting to? Why is not giving? Let's see. Let me see where the error is. Yeah. So let's see where the error is actually coming from, because I've actually worked on it before. Why is giving us issue inserting to values? should actually go. So we have in errors. Oh, it's there. I've seen it. It's there. I've actually seen it. It's there. So this one should not have value. So good. Now we should have data in our database now. Sync as near. Okay. We should be fine now. You can see now. So we have data inside our table now. So you can see now we have data inside our table. Now if I let's decide I want to insert another data now. You can see now it's telling us violation of primary key constraints because of a duplicate key. This is what I was telling us. Primary key can never be duplicate. It will only be unique. So let's say, for example, now I change this one to 2 now. Let's see what it's going to give us. You see now that data has went. The query ran successfully. So you can see now. So let's talk about the null that I was saying. If I'm removing it and I'm not putting anything there, there's a value I'm expecting it should give me if I'm not using that column. That column should be null. Column in supply does not match the table. So let me see my table design here. Okay, allow null. Yeah, so this place we can actually submit name. We do not necessarily submit name. We can actually leave it blank. Oh wow, what's happening? Please, are you following me? Are you following me? Hello? Can anybody hear me? Can you hear me? I hope I've not been speaking to myself since. Hello? Okay. So we can decide that a column should be blank and a column should not be blank. So I'll make this table. Let me go back to this table. So I'll update this place. So allow null to. So we can decide that we are not adding value inside it. So because I already have value inside, so it's not going. So subsequent table I'll be creating. So I'll be using it for it. So if I have to create a table using query, we write it like this: create. Call the name of the table we are creating. Let's say TBL products. We are calling products. Open bracket. Then call the name product ID. Int. The primary key. You can call the primary key like this. Comma product name. So I can come here and say not null. So let me close this place. Okay, let me add a foreign key. Let me add a foreign key to this place. So I will explain foreign key now. So we have a customer table. I can call it customer ID. Int. Comma. You close the table. Then create another table. You can see now we've successfully created another table. Same way we created table using the what's it called, the GUI the other time. In the same table we've actually created. You can see now we have two tables now. We have the customer table and the product table. So let's try to put data inside our product table. Insert into TBL products. So we only have what? Product ID. So insert into product values. We have one. I already said this place not null. So we must put something. So let's say, for example, I skipped it and I didn't put anything. I'm actually expecting a flagged error for me that should not go. the column and the column names match does not match the value. Actually expecting it not to give me this response, but why? What's happening? Insert into product table. Okay. Product name. Okay, so it's when so let me create another word here so I can easily pick it from someone be writing select staff from. So we have this second table now. So you see this place I set it to not null. What not null means is that a data must come inside this table. Just like we making a Google form required. That's the meaning of when we talk of null and what not null. So null means that they can decide not to fill that place. Then the query still should still run successfully. But by the time we'll be seeing results in our database, instead of seeing maybe logs now, we'll be seeing this value called null. And that's what it will be showing us. Means that what? That particular column, no, that particular field, no value was filled into it because it was set into it. But if there is any column that you did not want it to be blank, you want to make sure like a user submit a value inside it, make sure you put this not null. So what this null means that if you are submitting that data to the database, it will be telling you that that column must not be null, that column must not be null, which means that something must be submitted into it. So that's the difference between null and not null. That's what it's telling us. It must not either be blank or not be blank when we are submitting it. So I added a call. I even made a mistake. It should have been customer ID. So this key here you see now, customer ID int. We have it inside this place, inside this table. So let me run these two tables so I can see it very well. You can see now we have this customer ID. We have this customer ID in this first table. We have this customer ID inside this second table too. Pardon for this where we have the cost ID. It should have been the same way this one is too. So this key that we are seeing here now is foreign key. It's foreign key. So let me explain primary key and foreign key for us. So foreign key helps us to define relationship between two tables. One is the parent tables that need to have primary key uniquely to that table, that other table child. Table can have value of the primary key from the parent of one of the form of the column. Foreign key is used to enforce referential integrity, which I will be showing us too. Constraint ensure that value in the child table must exist as a primary key value in the parent table. So that's the meaning of foreign key, which means that we use it to create a table. So for this place now, if I'm creating my referential integrity, I'm saying that if customer name does not, if this customer ID does not exist in his parent table, which is this customer ID, we should not be able to insert any products inside this table at all. That's what this place is telling us. I think it should have been vice versa. If I should have used product ID inside customer table, I should have actually used product ID inside customer. So if a product does not exist inside this product table, customer should not be able to buy that product. That customer should be able to buy that product. That's what this creating relationship between your primary key and your foreign key is saying. It's just like you can't pick a bank account that does not exist inside our database. That's simply what when you create your primary key and your foreign key inside your database together. So I'll be showing us how we can create relationship between the two table now. So I will drop this table. I'll be deleting this table. So I'll be designing it more. So customer, drop table customer. So I'll be dropping the table So that's how to delete data inside your database. If you don't need the table again, you can drop the table. So I've deleted this table now. If you try to check it again, you can see now the table does not exist. So I want to delete the TBL product too. So I want to delete that too. I don't it doesn't fit what I want to do. So that's it. Fine. So I want to create the table afresh now. So let me use the GUI so that it will be faster. So new table. So I'll be calling the new table customer now. Customer. Let me create the product first. Let me create the product ID. Product ID. Data type is int. This int here. Come to this place. Primary key. I want to set it as primary key. So everything that I wrote inside my query when creating a table, you can actually do it here. You can see the name of the table, you can do it. Should it allow none? You want it to allow none, you can set it to yes or no. You can either put yes or no here. I want to turn on the primary key. Where did I turn on the primary key the other time? And this thing disappeared from my face. Okay, this is set primary key. This is it. So let me use this place to show us something more. You can see this place, we have what we call what? Identification, identity specification. What this place does is it will automatically be adding to our value itself. Immediately I just saw it, like, let me just branch it so that we have idea of what it does. So if you're having the table starting from number 1, if you're inserting data into that database itself, you don't have to be putting number 1, number 2, number 3. This place, once we turn it on, identity primary, when you say yes, it will automatically be picking data. It will automatically be adding that ID to the keys. But because they already made this place primary key, so it's not needed for this particular table. So product name. So this place should be virtual. So we don't want it to be null. So it must not be null. We are not allowing null. Then we have another one called let me put product ID. I think that's all, Abi. Okay, product category. Let's do product category. Product category should be named to. So we are done. So we save the table now. These are product table, TBL products. Oh, I already made the mistake, but it's fine, Sha. I don't want to allow notes, so we done with that. So it doesn't affect our data. We just ensure that we submit. So done. Let me see if the table has been created. Okay, we have the product table now. So let's design another table called customer table now. So I'll be using the foreign key here now. Customer ID. It will be int because we are dealing with the number. That as primary key. Then I'm going to have customer name. It should not be null. You must have customer, and then I'll be calling the primary key of product table here, which is the product ID. Which is the product ID. Let me try to see the column here. Let me try to see so that I'll spell that product ID. So I'll be calling it here now. Call it product ID. So this key that I'm calling now, This is the parent. The parent of that table is what? Product key, and is the primary key in that table. But me calling that primary key inside another table. So this space now will now be the what? Is foreign key here now. I don't know if we try to understand what I'm trying to say about foreign key and primary key. So this product key now is primary key inside this product table, but immediately I'm bringing it inside this customer table. That now makes it a what? A foreign key. That makes it now a foreign key, and I'm showing us how to use it more now. So I'll be saving this table, customer table, TBL customer. Okay, great. So I've created the table now. So this one, don't need this one again. No, close it up. So let's confirm the two tables we have created. Select star from TBL products. You can see now, you can see the two tables that we have now. So this product is primary key here, but this product ID now is now what? Foreign key inside this table. So let me start few data inside them. So let me start few data manually inside them so that we can try to product ID, edit top 200 rows. So was loading, why is taking time? Oh. Wow. If I know this thing will take time, I will have write the queries. Wow, this thing is taking long now. Oh, sorry, oh. I don't know why this thing is being there. I will have wrote the query to insert data into the database. Should I close it? Let me close it. So let me shut the server down. So I don't know why it's taking longer time. So let me shut it down. I think it's back. Okay, so we have product ID 1, the product name, let's call the product name sugar, the product category, let's call it beverages. So let's have another product. Oh, this thing is taking longer. Let me just close it and start again. I beg. Sorry about that. Yeah, it's actually dragging. So I want to create relationship using the primary key and the foreign key so that we can see how it's being used. But it's something that is very needed. A product that does not available inside the store now, customer must not be able to buy them. So can actually create that with it. So let's make continue of the queries that we are using. Connect. Okay, so let me open a new query. So I'll be inserting the table inside it manually, so it will be more faster that way. Okay, insert into insert multiple, you can insert data multiple value inside the database with this style. Can I have a Shegun? Let's put okay, let's put the product 2. Okay. Let me create for the product first. Product first valuation. Let me create for the product first. So let data be inside that thing first. Product side. Then perfect this. Yeah. Let's call this which name can we use again? Oh, Mick. Let's call this one which beverage, which category do we call it? Let's call it tonic, just for sample how it works. So I've created 3 rows inside this table now. Select. Our time has gone. Oh, I've not actually done much. TBL products. Start this next time. Okay, I didn't put phone. Okay, so you can see now that we have this table now inside our products now. So what thing I now need to do is I'll create relationship between them. I'll go to my table here, come down here, come to the keys. You can see this key here. Come to here, right click on it, modify it. Relationship, you go to relationship, add. You can see now we are creating a foreign key. Then we can come to this place to design. You can see now the primary table is what? Our primary table we are dealing with is the product table. Is the product table. Then we come here, we print the primary key for it, right? Then we come, this is the foreign table now. Then what's the primary key we are using? Product ID. We are using product ID. See now, so we've created a foreign key between. I can see now we're having what? Customer table, then we're having what? Product table. So we've created the relationship between these two tables now. Then we try to say the impact on it now. So let me try to insert into customer table now. TBL customer now, values, customer table. We having customer ID 1, customer name Shegun, The product ID. So you can see this is what we have inside our product ID is 1 to 4. So let me try putting 4 now. Let's see what it will tell us. It should not go. You can see now. Where is that place? It's giving us wrong error. Input from data type voucher. Customer name, it shouldn't give us any value error. Actually expecting an error. It's not actually bringing the error out. Input conversion data type voucher to bonnet is not allowed. Something is wrong. Let me try to put it to you. Let me see, maybe to go. There is an error somewhere. Oh. There is an error somewhere. But, water table TBL. So let me try to drop I want to drop a column. I want to drop a column there. Okay, so I've dropped the table, I've dropped the column. Now let me see, maybe to go now. Why are we having this why are we having this error now? Why now? Oh, this is where the issue is. Oh, Vine binary. Instead of using voucher, I wanted to use voucher. That's where the issue is. Can you see? This is where I made the mistake. That's why I made the mistake. It shouldn't have been Vine binary. That's where the issue is. That was why. Sorry about that. So that's the reason why we have to be very careful. Oops. So I have to alter that. I have to ask queries so to alter that too. So alter. You use the wrong query. So that's the code that we use. I'll copy the code for us. I have the codes here already. I have those codes here already. So I'll be pasting inside the chat for us before we end it for today. Author table, author column, product category. Product category. It should be voucher. So with this now, I've updated that. I've updated I think it should go. Yeah, let's go. Why is not going? Okay, let's just Google. Actually, should have been auto column in the database. Auto column. Let's see where the error is actually coming from. Okay, column. Okay. Column. Okay. Just like oh, okay, the no anything. Okay, fine. Let's go. Where is this error coming? If I tell this error, sorry, everyone. Query sometimes can be funny. One the next is okay. Okay, so it went. So let's try to insert table now. You can see now that we successfully inserted data inside this table. So let me bring out this table. Let me bring out the two tables. Select star from TDL customers. You can see now that I was able to insert this value inside it. So we were taught in our last class about using NAT join and query. So with this table that I've created a relationship between them now, and I know that okay, this product ID 2. What is the product name? Then it will return a what? Milo. Now let's say, for example, now I want to insert table now that does not exist inside this table. Then I'll call it 4. You know, like our products inside our customer table, we have customer ID, customer name, then product ID. But inside our product ID table now, we only have what soon 3. But now I'm now what inserting 4. So let's see what is going to tell us now. You can okay, violation here. So this one is a simple error. Let's see what's showing. So you should not go. The code actually supposed not to run, except our foreign key did not. The code supposed not to run. Supposed to have an error. Well, we're supposed to have an error because this table does not, this column does not exist. I'm coming. Let me see. Let me see. We're supposed to have an error in that place. Yeah. Actually, I have everything set. Everything is right. Suppose not to go because we are not having that value inside this our table. We have these have run it before. I've actually run and check everything before now. But some of what I'm trying to say is that when we create a relationship between our primary key table and our foreign key table, the product, the item that does not exist inside that table, we should not be able to what to insert into, because that value does not exist. So let's say, for example, now let me start more products. Let me start more item inside this customer table. We have 2. So let me start more now. Let me start 3. Let me call this place Pelumi. Let me call this place Pelumi. Then we have let me call this product ID 3. Let me call it 3. So if I'm inserting this, sorry, that's where error is. So okay. So now let's say, for example, now I want to delete this product now from this product ID. Now I want to delete it. We should have error. Delete. This is how to delete from database. Delete from, you call the name of the table TBL products. So, TBL products. Where we're taught how to use where product ID is equals to 3. Wow, this table is not actually linking the way I want. It's not actually linking the way I should not be able to delete. I should not be able to delete this table. So let me just come to the existing database that I've created before. This let me just try to see. I've created this one before, so I don't know. Just to show us what it does. TBL select star. I don't know why it's not working. So code can be sometimes, it can be sometimes funny like that. CBL star. Okay. So this is example of what I'm saying. I don't know why it's not working. So let's say, for example, now I want to delete this gender. I want to delete 2 from this gender now. Delete. delete from TBL where gender ID. You can see what I'm saying. This is the kind of error. This kind of error I'm actually expecting from this table. I don't know why it's not running. I'll just try to take us afresh. It's telling what the key statement conflicts with the reference constraint with the customer table gender, because what this table, this ID, let me run this place. See this ID that we are trying to delete, this gender, we are trying to delete gender ID 2 from this table, but we've already linked it to this place. So it's telling us that no, you will not be able to delete this gender ID 2 because another table, which is this customers table, is making use of this what? Is making use of this what? Gender ID 2. That means that you will not be able to delete what? This value from this primary table because another table is making use of it. So that leads us to what I'll quickly show us. Let me come to this table base we are working with. That will because what I'll be showing us. We have various ways to handle such situation. Since there is no much time, I'll just try to show us. So what should happen when you have that kind of situation, whenever you want to delete? That's where this place comes. Delete rules. If you want to delete, what should happen? Assuming I'm deleting now, we have two options: cascade, set null, set default. So what does cascade means is immediately you are deleting the primary key, you are deleting the row from that primary key. Any table that is connected to that value, it should be what? It should delete them. So what this place is saying, is simply saying is this. Now if okay, sorry, I'm not actually saving anything. I don't want to save it. So let's say for example now immediately I'm deleting this gender ID 2 now. Any row inside this customer table that is having this gender ID, you should delete them entirely. So people use this, database administrator use when they are deleting for, let's say maybe a staff that resigned in an organization now. Immediately they are deleting that staff ID from the organization. Every data, maybe the salary payment, the HMO payment of that staff, the whole data for that person should be what? It should be deleted easily. So that's what using primary key and foreign key, that's what it does. That's one part of it. That's what we call cascade. Then we have another option which I would actually love to show us, but due to because of our time, we have another option which is if you are deleting, what should happen to any foreign key? We have what we call what? Set null. This set null now means what? That place that you've linked it to that is representing that value, once remove it and put it blank. Let that place be blank. Let there be no value inside that column. That's what that place is telling us. Remove it and let it be blank. Then we now have another one, what is called what? Default. So what default means that okay, immediately we are deleting the foreign key that connected them together. We are deleting the particular ID from it. Set the column to a default. Then the default comes here. Let me try to bring out existing code that I've written before to show us how default works. Is that default is okay if so person is not submitting is it open somewhere? I'm expecting something to open, but it's not opening. Okay, see this place now. I have customer name, voucher, no default, no name. So what this place is saying that in case we've deleted the primary key, or in case the customer does not submit name, automatically represent it with what? No name. Instead of inside our database, instead of we trying to say nobody is submitting name, instead of you showing it blank, we can just put no name. So for this, I'll quickly show us how it's done. I'll quickly insert table inside this using this. I'll be changing the store. Sorry, I'm trying to round up. This part is actually wide. Design a database is really wide. Insert table, insert into customer. Then I'll call the column one by one. I'll call the cost ID. Then I intentionally will not put a name here. I will not put the customer name here. I intentionally will not put the customer name here. I'll go to cost segment and gender ID. You can say I set the gender ID 2 to 5 in case I didn't put any, but I'll be putting something there 1. Then I'll call it gender ID values. So customer ID, let's say 67. I don't know what I have inside that table. Segments, customer segments, let's say beverages. Then gender ID 2. Okay. Sorry. You can see now that this table ran and I did not insert the customer name. So now let's try to see what is going to show us inside that table. Select star from TBL customer. Sorry, you just have to. We can see now it's showing us no name. Can you see? Because I did not put any name, but it's picking it from this default. It's picking it from this. So that's how to use default constraints when we are designing our database. Immediately, maybe somebody is not putting his email address, and automatically maybe put it at something.com or anything. Instead of it being blank, then put something there. That's what this place, that's what it just did. So that one will take me to take us on another constraint that I called it what? Unique. So when we talk about unique, means that inside that particular column, we should not have duplicates. If somebody is bearing 10 now, that name, that 10 should not exist again. It should be only what? That person. That's what the function of unique constraint, just like working as primary key, but it's not primary key this time around. So I will quickly create a new table. Let me use the database we've been using before. I'll quickly create a new table. I'll just call it gender. Let me call it gender create table. Let me call it create table. Let me call it gender TBL gender. Then I'll call it gender ID int primary key. I actually love to write the codes out. Then I'll call it gender name, gender now. This one will be varchar 40. Then I'll call it it should not be null, not null, something must be there. Then I'll call it unique. This is how to call it. If you are designing your table and you want something to be unique, then I'll quickly run this table now and say it successfully ran. So if I come here now and I'm inserting data inside that table, insert into values, insert into TBL gender, let's say values, and I'm calling it first primary key is 1, and the second key, let me say I'm calling it a male. You can see now we've inserted data inside that database. So let me try to select data from it. Let's view it so that I can see what is inside it from TBL. Sorry, this database design is robust. So you can see now we have mail. So let's say for again now, I'm trying to insert this mail again inside it now. You can see it's not going. Violation of unique colon constraint. So it will not go because that particular column, I already set it that duplicate must not come inside that column. That's why, but let's try to change it to female now. Let's see, maybe it will go. Then it has what? Let's say we have boom. The query ran. See now. Can you see now that we're having female now? We're having female inside that column. So that's when we are designing a database, you can actually make use of this when you are dealing with, maybe you don't want to have multiple users. You want people to only single users should register. So you can put unique on the email address. Let's say, for example, now for user, you can say email address and put unique here. So if somebody that has registered for a seminar, a section, a course before now is not trying to register again, it's just be flagging it that no, you cannot. Your email address already exists, so you don't have duplicates inside that column. That's just majorly what this place, what it does. Unique, that's what it does. So we've covered the the main constraints. We've talked about the unique. Okay, remain check. So let me quickly walk us through what check does. We're almost done. Sorry, actually took time. The database design is actually robust something. So what check does is it confirms the data that the user is submitting inside the database. The example of this now is somebody age now cannot be lesser than today. If somebody is filling his date of birth now, it should not be putting what? It should not be putting today's date. It must be lesser than what? Today's date. So if somebody is putting his age now, it should not be able to put -5, -10, -20. If that's not an a age, because the age can never be negative. So you can apply a check constraint on that place that this is the check here. Check whatever value that is coming inside this column. Does it align? And I put the code here. Let me just try to copy the code for us. Okay, I'll be sharing the code. I'll be sharing the code with Pelumi. So Pelumi will share this place for us. So we have how to use the check here. This example here. So I'll be creating a table to show us how this check as well. You can see I'll be creating a table, call it person. I'll be creating a table, I'll call it person. So I'll be using this place, I'll call it person. Call it person, then I'll call this one, let's say, create a table person. Let's call this one person name. Person name. So this place is, you are entering the person name. It will be varchar. It will not be, what's it called? ABA number. So this 50 that I put here means the length of the character. That means if somebody is 50, you have up to, I think we have up to 255 that we can actually write inside it to make it trouble. Then this place, I'll be adding the age. I'll be calling this place now age. Age. Then I'll be calling the int. Then I'll apply the check. Check here. See now, check, bracket, age. Age what? Greater than what? Greater than 1. Let me use greater than 1. So I'll be using check greater than 1. Yeah. Okay, I'm supposed to put comma here so that it will go. So we've created a table called what? Person now. So let's try to insert into this table now TBL person. Now TBL person, person's name is, let's say, Shegun. I don't know, sorry anybody that is very Shegun on the call. It just for example. So let me try to put 0 now for the person's age. This code should not run. It should flag it for us. You can see now that code did go. What that are checking it for is what? It should be greater than 1, and 0 is not greater than 1. I don't know if anybody tried to get what I'm saying. Do you get what I'm saying? Can we leave a chat inside the box? Hello, can you see me? Can you hear me? Please, can you leave a message? I'm just seeing this, the screen is not showing. So can you leave a message for me if you can still hear me? If you can hear me, please leave a message in the chat box. Okay, thank you. Okay, thank you. So that's the work of check. Is a constraint that I used to check. So if a user now is now coming, now is now putting -21 now, it will not go. If you are putting -21, you are putting any value, if you are putting -23 now, you can see now, it will not go. You can see because it does not meet the constraint. It will return it. So now, we said it should be greater than 1. Let me try to put 1 here now and select. Okay. I'm almost done. Yes, I can hear you.
Yes, I wanted to ask, what is the duty of analytics to do? Because our time is fast spent.
Yes, I'm already done. It's just to touch these constraints that remain. We are done. Yeah, we are done. So if I'm trying to run this thing now, it will not go still because it doesn't meet the criteria. It should be greater than 1, but still it's not greater than 1. Then if I put 2 here now, it will go. You can see now. So that's how to make use of each of these constraints that I put them here. Default, check, not null, and null. So I've explained each and every thing. So when we are designing our database, it's very key for us to ensure that we follow these styles. Let's know our primary key, let's know our foreign key, let's know when to use our unique, maybe for phone number, for email, we can apply. And then for defaults, maybe somebody neutral age, it doesn't pick it. You can say if nobody is filling the age, it should be 30, it should be 25. And not null means that value must come in inside that database. It must not be blank. That's what that place is all about. So for these codes that you can all see here that I actually thought time will permit us so that I can test. I don't know, time will not be enough. So Mr. Pelumi will be sharing this. It will be sharing this code for us in case you want to design it. So let me show us a ERD diagram that actually did. So let me try to show us that one so you can see. So let me try to show the diagram. So how it will look like when we design our database. You can see now this is how it will be. If we have model our primary key, our secondary key, and code together, we are going to have something like this. Hey, this thing is really loading. We are going to have something like this. Is what we call entity relationship diagram. We are going to have the diagram here like this. Something like I put a sample here. This is how it will be at the end of the day, because we bring the table to each other. We bring the table to each other. So for the database optimization is when we are writing our code, let's try as much as make it light. We should not add unnecessary code. For example, time doesn't permit us. We have tried to practice some of these codes. This is what we are trying to get. Then if you want to optimize the table, simply write the codes in a small way. Don't try to select the whole data from your database. It will, imagine you're having 200 columns. It will take a longer time for that table for that query to run. So it's better you will select the specific column that you want to work with. I'm working with the name, with the region, with the year. Select it only. If this one is taking like 30 seconds to run, if you use this one, it can take like 2 minutes before it's going to give us the result, because it's what is taking the entire table, and that table is very robust. So just pick the table that we are working with. That's not what this page is telling us. Instead of picking the whole column inside the table, let's pick each field inside the table. So another one I actually wrote is, if you are working with query, this is the original query here. If you are working and you are having sub query, what you are nesting functions. It will take time because of what? Your table have to execute the one that's inside the bracket first, then it will now come out and execute this one. So it's better you don't write your simple query on a row. So it's going to execute this one once. Unlike this one, that you first of all go and execute this, where we have write employee ID 4, then now come out, then come and do this one. It will take longer time. So let's just find a way to always write our query on a straight line that will give us what? Simple answer that we need. So let me see what else I have here. Okay, changing the DB structures and the normalization is, try as much as possible not to have many tables. Denormalize your data. If you can merge the data inside a 2 table into one, please do. So it will make your table to be very simple. It will not make your database to be heavy, because mainly having more table, you are connecting table 1 to table 2 to table 3. It will take longer time for this query to run successfully. So I think that's all I have to say. So if anybody have questions, please you can leave questions. So let's take questions. Sorry, I took our time, right? Since database design is a bit robust, but I will try as much to cover it. So if anybody has a question, please let me know. If you have a question for me, yes, and you can ask anytime. Let's ask a question.
All right, thank you very much, everyone. Thank you, Paul. So if you have questions, as we do, just use the hand to please. So do we have anyone with questions? I just check anyone so I can allow you to talk. Just raise your hand, please. I know it's a whole lot. Database design and optimization is a whole lot. So is there anywhere you are not clear about? I'm not seeing any hand up. I'm not seeing anyone raising their hand up. So okay, probably people are still digesting what was taught in class. Probably when we watch the recording, if you have any questions, you can always drop it in the group. I think Adewale will add a board to the group, so you can answer questions and also share his social media handle, probably where you can reach out to him if you have questions. I know it's a whole lot, so I don't think there's anyone with questions. So I don't know if there's anything you want to say before we go today. Hello, Paul. Can you hear me?
Yeah, I can hear you. Thank you.
Yeah, we don't have anyone with question. I said, is there anything you want to say before
Somebody
we
is
say?
raising up his hand though. Somebody is raising up his hand. Pino no is raising up his hand though.
Let me just okay. Okay, you can talk now, please. It wasn't raising up his hand before.
Okay, unmute yourself and ask your question. Pino no, please you can ask your question.
Hello, can you hear me? Can
Very
you hear
well.
me?
Yes, I can hear you.
Okay. Thank you for the wonderful section. Even though it's quite complicating and all of that, but thank you for the section. Please, I want to ask a question. Okay, in a situation
Okay.
whereby you are running a query, maybe you said insert values into this, then you put the customer ID, put the age, and put the products. Then it happens that instead of it to give you just one table, it gave you like three, the same whatever thing you put there, and it gave you like 3 or 4, like is a duplicate. How will you remove it?
Okay, so to remove duplicates from the, so there's something called distinct. There's something called distinct inside let me share my screen again. Where am I? So best way to avoid duplicate is, once you have a primary key, let me just try to start your question from that place. Once you have a primary key, like the way we did in this okay, this place now is primary key, you will never have a duplicate in your table. Once that column, once your this place now customer ID here is primary key, you never have a duplicate in your table. You only have a duplicate if you do not have a primary key in your table. So it's very important to avoid that, to have a what's it, how will I call the name, to have a primary key for each table, so that there won't be repetition, because that's your dimension table. We must have been taught dimension table in our Power BI or Excel. That way you won't able to have what duplicates in your table. That's just the best way to tackle that from the beginning. So it's better we prevent issue of duplicates, so that when we are doing our modeling ERD diagram in SQL, we won't be having many to many relationship. We define it, we know our dimensions and we know our facts. So but in case if you didn't declare primary key on time, so what you can do next is using this function we call distinct.
Okay.
There's function that we call distinct. So this distinct will return only the unique value inside that particular column for you to see that okay, this is only what we are having. And we actually ask a big question, but time might not permit me to exhibit it. So there's something we called, you were taught last time, count. You were taught count, and you were taught an halving. I don't know, maybe we did halving. So this theory will actually guide in knowing where duplicates actually exist. So if, for example, now I've used my distance count, I'm saying that okay, I only have 20 unique items inside my table. Now I'm not saying that I'm having 40. So how many of each item actually exists? Then I can come down and say select count, that particular column, select count. I can put the select count star. Then we've done our goodbye before. Yeah, they've taught us goodbye and all. Then can I say having, then you call this whole table, this whole select count star greater than what should it be? Greater than 1. So once you do greater than 1, by the time this query run now, it will show us the column that actually have more than 1. Anyone that is 1 will not show. But anyone that is greater than 1 will actually show us the result. That by then we're able to know, like, oh, so this, let's say for example, let's say customer ID is TY67 now. It's not giving us 5. So we have idea that, okay, so this means that this customer TY67, we have it 5 times in our table. So you can now try to what? To be removing, you find a unique column in that column, maybe the phone number of that. Because if you are using, when you want to delete this ID now, if you are trying to use delete where this ID now, you will delete the whole, you delete the whole you delete the whole ID for that customer. So you have to be careful not to go and say where this customer ID is equals to TY67. We intentionally delete the whole data from it.
Yeah.
We delete the whole data from it. So what we can just do is this: find and select that data, select let's say customer ID. Let's say customer ID, maybe data for that customer phone number, something that can be unique, where customer ID is equals to, let's say, is equals to TY67. So this one now, it will return you all the details of that customer. Then you can now see the one that is not unique. It's like, okay, the phone number is not the same, the phone number is not, then can now start deleting where phone number is equals to 000, where phone number is still, you able to have what? One value that will belong to that customer. Because immediately you try to delete the whole what's it called, the whole ID of this customer, you lose the entire table. So we have to be very, very careful when we are deleting with ID, if you are trying to remove duplicate for your own questioner. But best way is apply primary key under your so that you won't have duplicates on it. Right, so that's it for that aspect. So Ayo, Mr. Pelumi will be sharing us this is a real lot. So actually try as much to see can. He'll be sharing this with us, and possibly if I'm added to the group too, anybody that is trying to create, we actually try to use it. But all this thing that we've done here, you can actually create it using this GUI as well. So it's not every time you be writing all this code. I know this code will be a lot to people, right? So we can actually make use of this GUI. You can create a table here. You can create a database from here, this new database. So you can actually do most of the things manually and you won't write code. But Mr. Pelumi will be sharing this page with us. We really need it. I actually thought we were able to cover them, but time doesn't persist here. I hope I answer your question.
Yes. Thank you.
All right, thank you very much. But yeah, this is what we're going to do. So Adewale is not currently available. So on behalf of Adewale, I just want to appreciate you. So let's appreciate our participation for today. It's not an easy one, coming down and even spending more